Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2004. So let's get started. First problem. Alicia earns $20 per hour, of which 1.45% is deducted to pay local taxes. How many cents per hour of Alicia's wages are used to pay local taxes? Okay, so since she earns $20 per hour, let's transfer that into cents because we want cents per hour. So $20 is 2,000 cents per hour. Right, so of this 1.5% is what we want. So 2,000 times 1.45%, which is 0.0145. This is equal to 10,000 times 0.0145 times 1/5, right? So this is 145 divided by 5, which is 29. So the answer is 29 cents. It's E. Number 2, on the AMC 12, each correct answer is worth 6 points. Each incorrect answer is worth 0 points, and each problem left unanswered is worth 2.5 points. If Charlene leaves 8 of the 25 problems unanswered, how many of the remaining problems must she answer correctly in order to score at least 100? She leaves 8 unanswered. That means she will automatically get 8 times 2.5, which equals 20 points, right? And now she has 17 problems left, and their sum has to be greater than or equal to 80 points, right? Okay, so 6 times what is greater than 80? 6 times 14, this is 84. So this is greater than 80, right? So 14 she has to get 14, right? So the answer is 14. It's C. Number 3, for how many ordered pairs of positive integers x comma y is x plus 2y equal to 100? Okay, so for x plus 2y to be equal to 100, we have to set values of y because x can be anything depending on the y, right? So y can be 1, 2, 3, 4, 5, all the way up to 49, right? Because if y would equals 50, then x would equal 0, but x has to be a positive integer. And so for every y value, there will be a corresponding x value, right? This would be 98, 96, etc. Up until 2, right? So there are 49 values. So there are 49 ordered pairs, which is B. Number 4, Bertha has 6 daughters and no sons. Some of her daughters have 6 daughters and the rest have none. Bertha has a total of 30 daughters and granddaughters and no great-granddaughters. How many of Bertha's daughters and granddaughters have no daughters? So since Bertha has a total of 30, but she has 6 daughters, that means Bertha has 6 daughters, and 24 granddaughters, right? Granddaughters. And if you see 24 granddaughters, she has no great-granddaughters, so they all have no daughters. All 24 have no daughters, right? Daughters. And since this is 24 granddaughters, which is 6 times 4, that means 4 of the daughters had granddaughters, 4 had kids, and 2 did not have kids. So 2 no kids, right? So this is also one of the people who didn't have daughters. So this is 2 no daughters, right? So the total amount of people is 24 plus 2, which is equal to 26, right? So it's 26. It's E. Problem number 5. The graph of the line y equals mx plus b is shown. Which of the following is true? First, this is the line, right? We can see that the slope is negative. So the slope is negative, and it is about 1/2, right? Because this is from this to this, so that just looks like about 1/2. And b this is also b is greater than 1, right? B is a positive number. And it's almost at 1 but not quite, so b is about, it looks like it's 0.8, and it's just estimates are enough because it's asking us m times b, right? And so if we look at m times b, first of all, m multiplied by b, that will be a negative value, so c, d, and e are out. And then since this is about 1/2 and that's about 0.8, then they can't be less than -1, right? So it has to be between -1 and 0, which is b. It's b. Number 6, let u equal 2 times 2004 to the 2005th power, v equal 2004 to the 2005th power, w equal this much, x equal this much, y equal this much, and z equal this much. Which of the following is the largest? Okay, so since there are too many 2004s cropping up here, just to make it easier, let's just say 2004. This is equal to a, right? This is equal to a 2005 plus a 2005, right? But then v is just 8 2005. If those are subtracted, then we just get 8 to the 2005th power And for v minus w, notice that this much, that's equal to 2004 to the 2004th power minus 2004 to the 2005th power minus 2004 to the 2004th power. So v minus w, that's going to be equal to this minus this plus that, right? So these two are going to cancel, so that's going to just give us 2004 to the 2004th power, right? So that's just going to give us a to the 2004th power, a to the 2004th power, and cw minus x, x equals two of those, right? So w minus x is just going to be minus, yeah, so that's just going to be minus a to the 2005th power minus a to the 2004th power, right? And then d is x minus y, so that's just going to be a to the 2004th power, a to the 2004th power, right? And then ey minus z, that's just going to be this minus this, so that's just 2004, right? 2004 to the third power times 2003, right? And so we want the largest out of these, and we can just see that it's this one, so the answer is A. Number 7, a game is played with tokens according to the following rules. In each round, the player with the most tokens gives one token to each player, to each of the other players, and also places one token into a discard pile. The game ends when some players runs out of tokens. Players A, B, and C start with 15, 14, and 13 tokens respectively. How many rounds will there be in the game? If you see here, first A, B, C, they start out with 15, 14, and 13, right? So first round will be the highest player, that's 3, is subtracted from that because 1 is given to B and 1 is given to C and 1 is discarded. So 15 minus 3, that will be 12. And then these two each get plus 1, so that's 15 and 14, right? And then the highest player, this loses 3, so that's 12. And then these two get added 1, so that's 13, 15. And then if we keep going, that's 14, 13, 12, right? Because these two get added 1, and then this one loses 3. And then we get 11, and then 14, and then 13, right? But then note that this time around, these values, they are 1 less than all of these values, right? So yeah, so if we split the thing here like that, then the first number, which is the smallest out of those 3, that's going to get 1 less, right? 1 less every time, right? This is getting 1 less. 1 less is going to be repeated 12 times, right? 12 times, and then until it becomes 1, 4, 3, and then 2, 1, 4, and 3, 2, 1, right? So it will reach 1, 4, 3, 2, 1, 4, and 3, 2, 1. And this is just 12 times because the next time that round will be 0, 3, 2, right? And so the game ends when some player runs out of tokens. So here, this player A, ran out of tokens, right? So this is our final round. And so we have 3 rounds of 12 times, right? And so this much, we had 12 times 3 equals 36 rounds. And this one, we just had 1 more round, right? So if we add these up, that's 36 plus 1, which is 37 rounds. The answer is B. Number 8, in the overlapping triangles ABC and ABE, they are sharing common side AB. EAB and ABC, they are right angles. AB equals 4, BC equals 6, AE equals 8, and AC and BE intersect at D. What is the difference between the areas of ADE and BDC? Right, so we want the difference of the areas between this one and this one. But then notice that since they're both sharing ADB, that difference is equal to that triangle minus this triangle, right? So we want AEB minus ACB, and that will give us the difference between those two, right? So what we want is AEB minus BCD, right? So AEB, this is going to be equal to 8 times 4 times 1/2, which is 16, and the BCD is 4 times 6 times 1/2, which is 12. So this is going to be equal to 4, right? So the answer is 4, it's B. Number 9, a company sells peanut butter in cylindrical jars. Marketing research suggests that using wider jars would increase sales. If the diameter of the jars is increased by 25% without altering the volume, by what percent must the height be decreased? Okay, so we have these jars, right? And then jars would be wider, but then the area is the same. But then the volume is the same, so the height will be decreased like that, right? Since the diameter is increased by 25%, that also means that the radius is increased by 25%, right? So if the first radius were 4, then the next radius, so the other radius would be 5, right? Because that's an increase of 25%. And since it asked by what percent must the height be decreased, let's just say that the first height was 100. And let's say that the percent decrease is x percent, right? So x percent decrease, right? And so if it's an x percent decrease, then this length will be 100 minus x, right? So since this is 100, x percent decrease will just make it 100 minus x. And so since we have the same volume, we can just use the equation, right? So this area is 16 pi, so 1600 pi, that's the volume. This is equal to 25 pi times 100 minus x. So 25 pi times 100 minus x. So these pi, they would go away. And so bringing that up here, that would give us 1600 equals 2500 minus 25x. Therefore, 25x would be equal to 900. And so x is equal to 900 divided by 25, which is 36. So our answer is 36. It's C. Number 10, the sum of 49 consecutive integers is 7 to the 5th power. What is their median? Okay, so we want the median of these 49 consecutive integers. And since this is an odd number, then the median is going to be equal to the mean of the 49 numbers, right? And this is also possible because these are consecutive integers, right? And so the median is just the mean of all the 49 numbers. This is the sum over 49, and since the sum is 7 to the 5th power, this is 7 to the 5th power over 49, which is 7 to the 2nd power. This is 7 to the 3rd power. So this is the answer. It's C. Number 11, the average value of all the pennies, nickels, dimes, and quarters in Paula's purse is 20 cents. If she had one more quarter, the average value would be 21 cents. How many dimes does she have in her purse? Okay, so let's say that she has n coins in total. Then pennies are worth 1 cent, nickels is worth 5 cents, dimes is 10, and quarters is 25, right? And so the average value is 20 cents, so 20n is the total amount in her purse. If she had one more quarter, so if she had 25 more cents, the average would be 21 cents. So it will be 21 times she would now have she would now have n plus 1 coins, so it's 21 times n plus 1, right? So this is equal to 21n plus 21. This is 20n plus 25. So if this goes over and this goes over, right, then that would just mean that 4 equals n. So that means he has 4 coins total. So total amount would be that would be average 20 cents. Therefore, it's 4 times 20 times 4, which is 80 cents, right? So that would be total 80 cents. And for 80 cents to be distributed among 4 coins, then the only way that's possible is to be 25, 25, 25, and 5, right? And so there will be 3 quarters and 1 dime, but then there will be no dimes. 1 nickel, but no dimes, so no dimes. So the answer is 0 dimes. It's 0, it's A. Number 12, let A equal 0,9 and B equals 0,12. Points A prime and B prime are on the line y equals x, and A prime and B prime intersect at C, which is 2,8. What is the length of A prime, B prime? Right, so let's just like that, right, and like this, right? So that would be a coordinate plane, and then we would have y equals x, that line, which is going to be this line, like that, right? And now let's just put on A and B points, which is 0,9 and 0,12. That would be about here, right? So let's say this is A and this is B, right? And we would have C equals 2,8. So let's just put that over here, right? So that would be C. This is 2,8, right? Then we would have 2 lines. One would go from here, crossing that line like that, and then one would go from A to C, right? And then it would cross that. And so this would be A prime, and this would be B prime. And so we can get each of these lines functions, right? So the orange line, this will be y equals negative 2x, and then plus 12, because this is 0,12, and so the rise over 1 is negative 2. And for the green one, the function would be y equals minus 1 over 2x plus 9, right? And so we can combine that with y equals x, right, to get this and this, to get those points. And so if we combine this one and this one, that means x equals -1/2x plus 9. So x equals 9 times 2/3, which is 6, right? And so x is 6. That means this is 6 comma 6. And if we do this and that together, then x equals -2x plus 12. So 3x equals 12, x equals 4, right? So this is 4 comma 4. And so our final length is we have 4 comma 4 and 6 comma 6, right? And so this length would be 2 and this length would be 2. And so therefore we have this length, which is 2√2 by the Pythagorean theorem, right? So it's 2√2, it's B. Number 13, let S be the set of points A, comma B in the coordinate plane where each of A and B may be -1, 0, or 1. How many distinct lines pass through at least 2 members of S? Okay, so if we say this is 0, 0, then the set of points A, comma B, they will be just all around it like that, right? Like this, right? And so this will be the 9 points. So this would be like 1, 1, this would be 1, 0, this would be -1, -1, like that. And so we need distinct lines to pass through at least 2 members of S, and we have 9 members of S. So the total possibilities is 9 choose 2, right? But then we have overlaps. If we have these two, or these two, or these two, they will all just be the same line, right? So since we have 3 overlaps, right, then that means that we need to subtract 2 times the number of overlaps. So -2 times the number of overlaps. And here, what I mean by overlaps is 3-point crossing lines, right? And so those lines will be this, and this. So we have 8 in total. So this whole thing is 9 choose 2 minus 2 times 8. So 9 choose 2 is 36, and then this is 16. So 36 minus 16 equals 20. So the answer is 20, it's B. Number 14, a sequence of 3 real numbers forms an arithmetic progression with a first term of 9. If 2 is added to the second term and 20 is added to the third term, the 3 resulting numbers form a geometric progression. What is the smallest possible value for the third term in the geometric progression? Okay, so we have numbers, the first term is 9, so we have 9 plus x, and 9 plus 2x, right? And so if we add 2 to the second term, so that will be 11 plus x, and 20 to the third term, that will be 29 plus 2x, right? So 9, 11 plus x, 29 plus 2x. So these would be a geometric progression. So this ratio is equal to this ratio, and if we write that in, so that will be 11 plus x over 9. So this ratio is equal to 29 plus 2x over 11 plus x. So this ratio is equal to that ratio. That's what this means. And if we cross multiply, then we will get x squared plus 22x plus 121, because it's 11 plus x squared. This is equal to 9 times 2x, which is 18x, and then plus 29 times 9, and that is going to be 261, right? So x squared plus 4x minus 140 equals 0, so x is going to be equal to 10 or -14, right? But then since we want the smallest possible value for the third term, and it just said real numbers, and so it can be negative numbers too. And so x will be -14. So if x is -14, 29 plus 2x, this is equal to 29 minus 28, which is 1, right? So the answer is 1, it's A. Number 15, Brenda and Sally run in opposite directions on a circular track starting at diametrically opposite points. They first meet after Brenda has run 100 meters. They next meet after Sally has run 150 meters past their first meeting point. Each girl runs at a constant speed. What is the length of the track in meters? Okay, so if we bring out this track right here like that, so that will be our track. And Brenda and Sally start at opposite points. So they will start at these points. Let's say that this one is Brenda. Brenda is the red one, and Sally is the blue one, right? So Brenda and Sally, they run in opposite directions. Since they run, let's say that Brenda ran this much, and then Sally ran this much, right? Sally would be faster, maybe. And so this would be where they first meet, right? We know that this is after Brenda has run 100 meters, so this is 100 meters. And since we don't know this value, let's say this is x meters. And then after this meeting, they will keep on running, right? So Sally will run like this much. Sally will run like that, and then Brenda will run like this, right? So this is Sally, and this is Brenda. And so Sally will have run 150 meters, right? So this is 150 meters, and since we don't know this much, let's say it's y meters, right? So it asked what is the length of the track in meters, right? So if we know just one of x or y, then we can just get the answer. Okay, so first of all, let's compare. Yeah, so first let's use the fact that Brenda's speed is going to be constant compared to Sally's speed, right? And so Brenda to Sally for the half running, that would just be, yeah, so Brenda to Sally, the distance run, which equals the speed, right? Because there's the same time, the time is same. So this is equal to 100 to x, and this is equal to y to 150, right? So that's equal to y to 150, and so xy equals 15,000. So y would equal 15,000 over x, and now we can use the fact that that much equal to this whole thing, right? And so this should be x, right? And so 2 times 100 plus x, this is going to be equal to the whole thing, which is 150 plus y. 150 plus y, so 200 plus 2x is going to be equal to 150 plus, and then right here in y, let's put this one, right? So if we do that, it's 150 plus 15,000 over x, right? And so 2x plus 50, this is equal to 15,000 over x. So if we multiply x to both sides, that's going to be x times this much. And so 2x squared plus 50x minus 15,000, this is going to be equal to 0. And so if we factor this, then we're going to get x can be equal to minus 200 or 150, right? And since x obviously has to be a positive number, x will be 150 over 2, right? So it's either this or this, right? And since x has to be a positive number, this is what x is. So x equals 150 over 2, and that's just 75, right? So that's 75. And so what is the length of the track in meters? The length, this is equal to 2 times 100 plus x, right? Because this 100 plus x, that's just half of the whole thing. So this is going to be equal to 2 times 175, which is equal to 350, right? So this is 350. The answer is C. Number 16, the set of all real numbers x for which this is defined is x is greater than c, right? What is the value of c? Okay, so since this has to be defined, that means that the value within the log, so this value, that has to be greater than 0. So this value, which is within this log, has to be greater than 0. So let me write that again. Log of 2003, log of 2003, of log of 2002, of log of 2001, x, this has to be greater than 0. If we make everything a power of 2003, so 2003 to this power is greater than 2003 to the 0th power, right? So that would just make these two go away, right? So that would just make it like that. And 2003 to the 0th power, 2003 to the 0th power, which is, that's just equal to 1. So this is 1, right? And so so if we do the same thing with 2002, so if this goes over there, then that will be just log of 2001, x is going to be greater than 2002 to the 1st power, which is just 2002. And lastly, if we do the same thing with 2001, if that goes over there, then x is going to be greater than 2001 to the power of 2002. And this is right in this form like that. So where's the value of c? This is c, it's b. Number 17, let f be a function with the following properties. F1 is 1, and f2n is n times fn for any positive integer n. What is the value of f and 2 to the 100th power? Okay, so let's kind of write out, so let's test out x values and their corresponding f values. So f of x values, f1 is 1, so x is 1, then that means fx equals 1. And then, but we want it to be like factors of 2, multiples, powers of 2. So x would be 2 to the 0th power, and fx would be 2 to the 0th power also. If x is 2 to the first power, so that's just 2. Then f2n, that would just be n is equal to this one, right? So that's 2, so it's 2 to the 0th power times 2 to the 0th power, which is 2 to the 0th power, and x2 to the x2 squared, that would be, so that would be this one, n, so this is just 2 to the first power, and this would be fn, so this is going to be 2 to the 0th power. If those are multiplied together, we're going to get 1 plus 0, which is 2 to the first power, right? And then if we have 2 or 3, then we're going to just have the same thing. These and this are going to be added together to make 2 to the 3rd power, right? So 2 to the 4th power, that will make these two added together, which is 2 to the 6th power, right? And then now if we just look at these things, we have plus 0, from here to here, plus 1, plus 2, plus 3, like that, right? And so if we go all the way to x is equal to 2 to the 100th power, right, then we're going to have 2 to the, we have 0 plus 1 plus 2 plus 3 plus all the way up to 99, right? So this is 1 plus 2 plus 3 plus 4 plus all the way up to 99. And so this much is going to be, that's going to be 99 times 100 over 2, which is 4950, right? So this whole thing is going to be equal to 2 to the 4950th power. So this is the answer. It's D. Number 18, square ABCD has side length 2. A semicircle with diameter AB is constructed inside the square, and the tangent to the semicircle from C intersects side AD at E. What is the length of CE? Okay, so for this one, we can just draw some lines, and then we will just get our answer. So if we have that line, and if we draw a line from this to that point, like that, so that this is like that. And then lastly, we want a line from here to the center, so that will be our last line. So since it has side length 2, this is 2. So this much is 2 and 2. Sorry, this much is 1 and 1, right? So this radius, that would also be length of 1. So that would also be length of 1. Let's write it here. That would be length 1. And then we know that since this angle and this angle, they're equal, and this angle and this angle, they're both 90 degrees. So this triangle and this triangle, they would be so they will be congruent, right? And so now we know that this angle and this angle, they are the same, and so we can say that since BC is length 2, then this much is also length 2, right? So this much is length 2. And then we don't know this length, and to get the length of CE, so to get the length of CE, all we need to know now is this length, right? And so let's say that this length, that's just x. This is x, right? And then now we see that since this is a right angle, this triangle and this triangle, they are they are similar triangles, right? So these two triangles, they are similar triangles, and so we know that x over 1, that would equal the ratio of 1 over 2, right? So x over 1 equals 1 over 2, so x is equal to 1 over 2, right? So since we want the length of CE, and we now have this much is 2 and this much is x, which is 1/2, that means this is 2 plus 1/2, so 2 plus 1/2, which is 5 over 2. So this is the answer. It's D. Number 19, circles A, B, and C are externally tangent to each other and internally tangent to circle D. Circles B and C are congruent. Circle A has radius 1 and passes through the center of D. What is the radius of circle B? So we would have the so we would have the center of circle D at this point right here, because circle A passes through the center of D, so this would be the center. And now we want to draw lines from this point to the tangent lines, to the points of tangency of circles A, B, and C, right? And like this, right? So these lengths would all be equal, but then notice that this length, that's just the radius. No, sorry, that's just the diameter of circle A, right? So since that's the diameter of circle A, that's just length 2. So this is 2. Therefore, this length is also 2, and this length is also 2, right? And now let's set the midpoints. So let's set the centers of the circles B and C and connect them. If we do that, then now we see that this much is the radius of the circle. So let's say that much is x, right? So if this is x, then this would also be x. So this is x2, and so this is also x, and this is also x, right? and then since this much is 2, right? So the so the whole thing is 2. So that since this is 2 and this is x, that means we know this length, that's going to be 2 minus x, right? So that's 2 minus x, and this much is going to be 2 minus x also, right? And then now we can use the Pythagorean theorem, because if we put on this side like that, right, then we will have this triangle, and that will be a right triangle because this is a right angle. From the Pythagorean theorem, we can get this length, right? So that length, let's call it a. So a is gonna so that length is gonna be equal to root of hypotenuse squared 2 minus x squared minus this much squared, so x squared. This is equal to root of 4 minus 4x, right? So this is gonna be 2 times root 1 minus x, right? And so since this is 2 times 1 minus x, now if we draw a line from the center of A to the center of C, like that, right, then this length would be, this is the radius plus radius, so this is going to be 1 plus x, right? So that's going to be 1 plus x. And now we can, yes, and now since we know this length, that's 2 times 1 minus root x, so 2 times root 1 minus x, and this is also 1. And so now we can just look at this right triangle, right? That would be a right triangle, and so now we can look at that value. We can use Pythagoras now for this one. So if we use Pythagoras, we're going to have 1 plus x squared, 1 plus x squared. This is going to be equal to x squared plus, and then this much, which is 1 plus 2 root 1 minus x, 2 root 1 minus x squared, right? So if x squared goes over, then x squared and x squared cancels. So it's 2x plus 1 equals 1 plus 2 root 1 minus x squared. And so if we do that, then that's just going to give us 1 plus 4 minus 4x plus 4 root 1 minus x, right? And so these 1 and 1, that's going to cancel. And so if we bring this over there, then that's going to make it 2x plus 4x minus 4, so 6x minus 4 is going to be equal to 4 root 1 minus x. And so if we divide by 2, that means 3x minus 2. Yeah, so 3x minus 2 will equal 2 root 1 minus x, right? And so now if we square both sides, then we are going to get 9x squared minus 12x plus 4 equals 4 times 1 minus x, so 4 minus 4x. So these two are going to cancel, and we can divide by 1x, so this is going to cancel. And so 9x equals 12 minus 4, which is 8. X is equal to 8 over 9, right? So the answer is 8 over 9, it's D. Number 20, select numbers a and b between 0 and 1 independently and at random, and let c be their sum. Let a, b, and c be the results when a, b, and c respectively are rounded to the nearest integer. What is the probability that a plus b equals c? For this one, let's say let's say we will draw like a coordinate plane type of thing. So this will be a and this will be b, right? So this will be 0, and the maximum value of a would be 1. Let's say 1 is here, and the maximum value of b would be 1, like that. And so our total like values that we need to choose from, that would go like that, right? And so this will be our total area from which we can choose a and b from. And now we have 1/2 and 1/2, right? Because whether a is less than or greater than 1/2, that determines whether large a is 0 or 1, right? And so we can have that and that, same thing for b right there. And so we can have 3 values of c, right? We can have 3 values of c. Either c can be 0, or c can be 1, or c can be 2, right? So first case is if c is equal to 0, that means a is equal to 0 and b is equal to 0. So these both mean that a is between 0 and 1/2, is between 0 and 1/2, and b is also between 0 and 1/2, right? And from here, since c is equal to 0, that means small c, so small c, a plus b, that is, because small c is a plus b, is less than 1 over 2, right? And so for this to happen, since this is a and this is b, we will have it like this. So this will be, so this will be the line where a plus b equals 1 over 2. And since a plus b has to be less than 1 over 2, then we will have our possible points at this much, right? And that's because a and b are between 0 and 1/2, so this is the points that we can be. And for c equals 1, we can have a equals 1 and b equals 0, or a equals 0 and b equals 1, right? So if a is 1 and b is 0, that means a is greater than 1/2 and less than 1, and b is and b is between small b is between 0 and 1/2, right? And so this gives us, and these both give us that a plus b must be greater than 1/2 but less than 3 over 2, right? Because that's the only way for c to be 1. And this bottom one, that is where a is between 0 and 1/2, like that, right? And b is between 1/2 and 1. And so if you see a plus b equals 1/2, that's just this line, and a plus b equals 3 over 2, that will be this line, like that, right? And so so since a plus b has to be between, it just has to fall right here. But then these what do you call it, those areas, they're just here and here, right? So since they all fall within those values, then every value within those ranges are fulfilled, right? So we have the blue areas also, and now where c is equal to 2, then we would have a is equal to 1 and big B is equal to 1, right? And so these would make us, so these would give us that a is between 1/2 and 1, and b is also between 1/2 and 1, right? And this time the case would be that a plus b is greater than 3 over 2. A plus b is greater than 3 over 2, right? So this is 3 over 2 line, and since a plus b has to be greater, then we are right here, right? So what we want now is the total shaded over the total, right? So it's the shaded over the total. If you see, this is 1 square, this is 2 squares, and then these two combine to form 1 full square, right? So this is 3 over 4 total squares. So this is 3 over 4. That's the answer. It's E. Number 21. If the summation of n is 0 to infinity of cosine 2 n power theta equals 5, what is the value of cosine 2 theta? Okay, so let's just list it out and see what we're dealing with. So it's cosine 0 power theta plus cosine square theta plus cosine to the 4th power theta all the way to infinity, right? And this is sum is equal to 5, right? And then if you just look at the numbers alone, we can see that we are having a geometric sequence, right? And then this is just going to be an infinite geometric series. So so the sum, which is 5, this is going to be the first value, which is cosine to the 0th of theta. So cosine 0 theta all over 1 minus the common ratio, which is cosine square theta, right? So this is 1 over 1 minus cosine square theta, right? And so that means 5 times 1 minus cosine square theta is equal to 1. So 5 minus 1 equals 5 cosine square theta. So 5 minus 1, that's 4. 4 equals 5 cosine square theta, right? So cosine square theta equals 4 over 5, right? And since we know that cosine square theta equals 1 plus cosine 2 theta over 2, that means cosine 2 theta is equal to 2 cosine square theta minus 1, right? Since we can plug this value into here, then that will give us 2 times 4 over 5 minus 1. This is 8 over 5 minus 1, and this is equal to 3 over 5, right? This is 3 over 5, so the answer is D. Number 22. 3 mutually tangent spheres of radius 1 rest on a horizontal plane. A sphere of radius 2 rests on them. What is the distance from the plane to the top of the larger sphere? Okay, so if we don't look at the sphere of radius 2 yet, and make a diagram, this is what it's going to look like from the top, and this is what it's going to look like from the side, right? So this is not considering the sphere of radius 2. So these are all on a horizontal plane, so it's going to be on this surface, right? On this surface. And first of all, yes, and then if we connect the centers of these spheres, then that will just going, so then that's just going to be an equilateral triangle, right? And so since the radius is 1, that means this much is 1, so this much will be 2, right? So since this is 2, 2, 2, so since this is 2, that means this much is 1. And so if we draw a length right here, that so that means if we have the centroid right over here, this is the centroid. So if that's the centroid, then the length ratio is going to be 2 to 1, 2 to 1, and so this length is going to be 2 over 3 of this entire length, right? So if we want to get that length, this is going to be 3 over, that's going to be 2 over 3 times this entire length, which is 2 times root 3 over 2. So this is 2 root 3 over 3, right? So that means that the distance from the center, so the distance from the center to 1 center, this is going to be 2 root 3, that's going to be 2 root 3 over 3, right? I'll just write that again, 2 root 3 over 3, so that's going to be this length, so that's going to be this distance. And now, since this is a sphere of radius 2, if we mark the center, and then if we draw a line like that, then we can know that this whole thing is 3, because this is radius 2 and this is radius 1, so that means that this whole length is going to be 3, right? So that length is going to be 3. And now if we draw one more line from here to here, we can know the distance, the vertical distance from the center to the center, right? So that's going to just be the vertical distance. And since this is a right triangle, if we use Pythagoras, this is just going to be root of 3 squared minus 2 root 3 over 3 squared. This is going to be root 9 minus 3, that's going to be root of 9 minus 4 over 3. And this equals root 27 minus 4 over 3, which is root 23 over 3, right? So this is root 23 times 3, which is 69, root 69 over 3, right? So now we know that this distance is root 69 over 3, root 69 over 3, and we also know this distance, right? Because that is just the radius. So this is going to be 2, and we know this length 2 because that is the radius of the smaller one, so that's just this. So this is going to be 1, right? And so now we can just add up this one, this one, and this one. And so to get, we have 2, we had 2 plus 2 over here, plus this much, which is this much, root 69 over 3, plus this last one, which is 1. So this is 3 plus root 69 over 3, and so this is the answer. It's B. Problem number 23. A polynomial px equals this has real coefficients with c 2004 is not 0, and 2004 distinct complex zeros, the zk equals ak plus bki. And k is between 1 and 2004, and ak and bk are real, and a1 and b1 equals 0, and this is also true. And which of the following quantities can be a non-zero number, right? So 4 of these are 100% zeros, and 1 is not, right? Okay, so first of all, let's look at this one. The sum of roots, the sum of the roots is just going to be negative c 2003 over c 2004, right? But then since this is a real number, right? This is a real number, but all our roots are complex numbers, right? So that means the sum of all the bk's, sum of b1, b2, b3, all the way to b 2004, this is going to be equal to 0. But then the sum of all these, that's just equal to the summation of k equals 1 to 2004 bk, right? bk, and so this value is just this value, so this is equal to 0. That means summation of ak, so summation k1, k is 1 to 2004 of ak, that's equal to 0, right? So that means this is equal to 0, so D is wrong. So D is 100% 0, right? So this is equal to k equals 1 to 2004 of a k, right? So so since they're both 0, that means the total sum is equal to 0, right? So that means the sum of the roots is going to be 0, right? Because the sum of the a's is 0 and the sum of the b's are 0, so the whole sum, this is going to be 0, right? So that just gives us that c to d 2003, yeah, so c 2003, this is equal to 0, right? So we have so we have one more. So our first one was that this is 0, so this was our first one that gave us d is out, and then and then now this c to d 2003 is 0. This is our next one, so that gives that b is wrong, right? And then now let's look at these two things, right? Zk is ak plus bki, but a1 equals b1 equals 0, right? And so that means that z1 equals a1 plus b1 b1i, right? Since this is 0 and this is 0, it's just all going to be 0, so z1 equals 0. But then this is the constant, right? This is the constant, so that means this is the constant, so c0 is also 0. c0 is also 0. So this is something new, so that's also what we have. So a is also wrong, a must be 0. So now we have c and e left, right? So first let's say if e is equal to 0. If e is equal to 0, then there is a root of, then there must be a root of 1, right? So 1 as a root, right? And then this one would be equal to that means root of 1 plus 0i, right? So we have a root in form of 1 plus 0i, and then this means that we are so this means that for some k that is not 1, right, we are going to have bk is equal to 0, right? For some k that is not equal to 1, bk is going to be 0. So that means that b2 times b3 times b4 times everything up to b2004, this must be 0, right? Because one of these is 0, therefore the whole thing multiplied is 0. And so that would give us that e is 0 and c is also 0, right? So this means that e is 0 and c is also 0. So that would give us no answers, right? And since the answer must exist, e must not be 0, right? So e is not 0, therefore e is the answer. It's E. Problem number 24. A plane contains points A and B with AB equals 1. Let S be the union of all disks of radius 1 in the plane that cover AB. What is the area of S? Okay, so let's bring out this one. Let's say that this is the line AB. So this is A and this is B, right? And AB is equal to 1. And for S to be the union of all disks of radius 1 in the plane that cover AB, so if we have a circle like that, that have this as the radius, then one endpoint would be here, and it can be maximum over here, right? So right here, then its radius would be about like that, would be the diameter, and this can just swing around with point B as its axis to this point, right? That's the maximum it can go, and that way it would go like that, so that would be the diameter, right? So this is the maximum that this can go. And if this goes down, same thing, we would have this equal to, so that will be, this length will be the diameter, right? And so if we connect this, then that would be that would be the full area that this circle can go through when it's like going around B as its axis, right? As its like center point, right? And we can do the same thing to the other side like this. And so here the this would be the farthest, so we have a radius here, and we have a diameter here, and so if this moves like that, right, then the diameter would be something like that, right? And then if this goes down, the diameter would be something like that, and so connecting we would have something like that. So that would be 1/3 of the circle, with this as the radius. And then lastly, something different is that if we have this, it kind of doesn't look like it, but this region, that must be, yeah, so this is technically, and then we would have parts of circles at here, and the same thing down here. So we would have this kind of fan shape, like pizza pie shape right there, right? And so if we draw this more accurately, right, then we are going to get something that looks like this, right? So like that. If you see, so this much is going to be our 1/3 of the circle, and this is also going to be that same 1/3 of the circle, and this is going to be our 1/6 circles, right? And so our total area, this is 2 times the blue, right? Because the blue is this much, right? So this much will be the blue, 2 times the blue, so that and this, right? And then we can add the 2 red, right? Plus the 2 red, plus 2 of red, and then if you see these two, they are overlapped length, right? So these two have overlapped, so we have to subtract 2 of the overlapped, so subtract 2 of the green, right? And we also know that AB equals 1, right? And so now so now we know that this is 1, therefore this thing, so that radius, this is going to be equal to 2, right? So since the blue is 1/3 of the whole triangle, 1/3 of the whole circle, so this is going to be 2 times 1/3 of the circle with 2 as the radius, so 2 squared pi, and then plus 2 times red, so plus 2 times, and then this is 1/6 of a circle with 1 as the radius, so 1/6 of the circle with 1 as the radius with times 1 squared pi, and then these are just equilateral triangles with side length 1, so this is just going to be minus 2 times root 3 over 4 times 1 squared, right? So this is all going to be 2 times 4 over 3 pi plus, so that's just going to be 8 over 3 pi, plus this much is 1 over 3 pi, and then we have minus this much, which is root 3 over 2. So this is 3 pi minus root 3 over 2. So this is the answer. It's 3 pi minus root 3 over 2. The answer is C. Number 25. For each integer n is greater than or equal to 4, let a denote the base n number 0.133n. The product a4, a5, all the way to a99 can be expressed as m over n factorial, where m and n are positive integers and n is as small as possible. What is the value of m, right? Okay, so first we can express an, which is 0.133 at the base n, right? This is going to be equal to n cubed minus 1, and that's all under n squared plus 3n plus 3. Because if you see 0.133, this much n, this is going to be 1 over n plus 3 over n squared plus 3 over n cubed plus 1 over n fourth plus 3 over n fifth, etc. And then if we have n cubed times that, so n cubed times 0.133n, so this is going to be n squared plus 3n plus 3 plus 1 over n plus 3 over n squared, and so this part is going to be equal to this whole thing, right? So this much is going to be equal to 0.133 forever n, right? And so if this goes away, so if this goes to there, then n cubed minus 1 times 0.133n is going to be n squared plus 3n plus 3. So if we move this down there, then we're going to have 0.133n, which is an. This is going to be equal to n squared plus 3n plus 3 over n cubed minus 1, right? So this is why it's this one right there. And so now if we go back to our calculations, this will mean that this thing is equal to, if we multiply by n both sides, then this is going to be all over n times n cubed minus 1, and then this is going to be n cubed plus 3n squared plus 3n, and then if we do plus 1 minus 1, then this is going to be n plus 1 cubed, right? So this is going to be n plus 1 cubed minus 1 all over n times n cubed minus 1, right? And so this is our value of an, right? And then if we just write out everything in this form, then we would get, what is it? We would have a4, a5, a6, all the way to a99. This is going to be equal to, if n is 4, so this is 5 and this is 4, so it's 5 cubed minus 1 over n, which is 4, times 4 cubed minus 1, right? And then this is that multiplied 6 cubed minus 1, and 5 times 5 cubed minus 1, so that's when a is 5, yeah, so that's when n is 5, so, and it's that times 7 cubed minus 1 over 6 times 6 cubed minus 1, and this is multiplied by 8 cubed minus 1, 7 cubed minus 1, right, like this, all the way until we have 99 cubed minus 1 over 98 times 98 cubed minus 1 times 100 cubed minus 1 over 99 times 99 cubed minus 1, right? And then now we see that these two cancel, this one and this one cancel, these two cancel, all the way up to this one, which cancel up to this one, like that, right? All the way. And then now we see that the only ones that are left is 4, 5, 6, 7, 8, 9, 10, all the way to 98 and 99. And then that, as well as 100 cubed minus 1 and 4 cubed minus 1, right? So this is all equal to, 100 cubed minus 1. So 100 cubed minus 1 over, and then 4, 5, 6, 7, all the way to 99. That times 4 cubed minus 1, right? And since 4 cubed minus 1 is just 63, this is 63, right? And then since we have 4, 5, 6, 7, all the way to 99, we are missing 1 times 2 times 3. So if we just multiply that, right, then this will be also multiplied by 1 times 2 times 3, which is 6. And so this is going to get us, this much is 99 factorial. So it's all over 99 factorial times 63. And this much is 999 times 6, right? And so if you see here, this is 99 factorial and this has 3 99s in it. That means we can divide both the numerator and the denominator by 99. So that's going to give us 10101 times 6 over 98 factorial times 63, right? And so if we divide 3 from each side, this is going to give us 2, this is going to give us 21, right? This is equal to all over 98 factorial, and this is 10101 times 2 divided by 21, right? So this is m over n factorial, so this is n, and this would be m, right? So this is m, and so if we want, and so this is what we want to get, this is m. So if we do that, this is 10101 divided by 21 times 2, and this is equal to 400, this is equal to 481 times 2, which is 962. So this is our answer, it's 962, it's E. So that was it for the AMC 12A from the year 2004, and thank you for watching.